Okay, these notes are gas stoichiometry notes. Okay, so let's start with volume to volume. Now, volume to volume is done just like mole to mole. So if you remember in stoichiometry, last unit, when we went from one mole to the next moles, we only had to use the mole ratio. Well, that's pretty much what we're doing here, only we call it the volume ratio. So as long as the temperature and pressure remain constant, doing a volume to volume stoichiometry problem is rather simple. Okay? Basically, it's the volume given. You're going to put it in a picket fence, and then you put your volume ratio here. And that comes from the equation, just like the mole ratio. So the volume ratio is the mole ratio from the equation, but with liters as the unit instead of moles. So just like you would do the mole ratio, these are the two numbers that come from the equation. Let's look at an example. Okay. What volume of oxygen gas is needed to produce 12 liters of water vapor? Okay, so we start out with 12.0 liters of H2O. Okay. Now, if we were doing moles, okay, we would put the H2O down here, but I'm going to put an L instead of moles. And then we're looking for oxygen gas. So we're going to put the O2 up here. Well, the two numbers come from the equation. So this is 2 for the water and 1 for the oxygen. Okay, so this is 12 divided by 2, which is 6.00 liters of O2. These are very, 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 very simple. Okay? They don't get hard or difficult or whatever you want to call it until we get to mass and volume. Okay, in order to do mass to volume gas stoichiometry problems, we will need to use the ideal gas law as well as picket fences. Okay, so when you start out with a mass, we're going to use the picket fence first. So first step, you're going to have your given mass here. Your molar mass is going to go here. Now I'm going to put it as a division question so that you know the molar mass part's on bottom and the 1 mole part is on top. And then you're going to do your mole ratio. Now, once you do this picket fence, this comes out to be moles, which is N in your ideal gas law equation. And you're trying to calculate volume, so it's N RT over P. Okay? So you're going to take this number that you calculate number 1 and put it into number 2. Okay, well, let me put the gases down. Let's see. The weights down. 32 grams and 159.7 grams. Okay, so what volume of oxygen is needed to produce 125 grams of rust? So that's what we're starting with. At 25 degrees Celsius, which is 298 Kelvin, and 897 millimeters of mercury. Okay, so let's do this. We have now the next step, you know, is the molar mass. So it's going to be 159.7 grams of Fe2O3, 1 mole of Fe2O3. Okay, we got so far this much. Now we need our mole ratio. So this is 2 moles of Fe2O3, and remember, it's always what you have on the bottom and what you want on top. Okay, so everything cancels out. Now, when you do 125 times 3 divided by 159.7 divided by 2, you're going to get 1.17 moles of O2. That's not the final answer because we want the volume. So now you're going to do, of course, we're trying to find V. N equals 1.17 moles. R, well, we don't know what the R is yet, except for we look up there, it's millimeters of mercury, so we know it's going to be 62.4. because our P is 897 millimeters of mercury. Those are the numbers we're going to stick into the ideal gas law equation. Now, if you don't want to write all those, I know I keep making you normally, but with gas stoic, I'm not going to. But you do have to put the units into then the equation. So if you want to write all this stuff, then write it like I'm doing in blue here. So we're going to put 1.17 moles times 62.4. That's the only one you don't have to have a unit for. 298 Kelvin. This way I know that you know the right units. 897 millimeters of mercury. When that's all said and done, you get 24.3 liters of O2. Okay? Pretty easy, I think, anyway. Okay, let's look at another one. First, let me put my... Okay, so what volume of oxygen is needed to react with 95.8 grams of iron? At STP. Okay, so next step is the mole ratio. 4 moles of Fe, 3 moles of O2. Do this, and we get 1.29 moles of O2. Put that into our equation. 1.29 moles. Okay, now 0.0821 and 273 Kelvin all over 1.00 atm. Okay, 28.9 liters of O2. Pretty far, or pretty, yeah, it sounds pretty easy so far. Hopefully the rest of it is. Okay, volume to mass. Volume to mass calculations also use the ideal gas law equation and picket fences, just in the reverse order. So in other words, you're going to do the ideal gas law equation first and then put that number into the picket fence. So we're going to calculate moles this time. So 1, N equals Vp over RT. Okay? Now you're going to put that N into a picket fence. So you're going to have your mole ratio. And then you have your molar mass. Now this time, instead of dividing by a molar mass, we're multiplying. So you know it goes on top. Okay? Okay. Once again, let me put my... Okay, so how much iron is needed to react with 26.8 liters of oxygen at 298 Kelvin, because you have to turn them into Kelvin, and 109.0 kPa, which means my R value is going to be 8.341. Okay, so N equals, as I said, if you put your units in here, you'll be fine. 26.8 liters, 109.0 kPa. What the heck? Okay, over 0.341 with no units, and then 298. Okay, sorry about that pause in there, guys. One of my programs just started up and hid my explain everything file. So, oh well. 1.18 moles of O2 is what that equals. Well, how much means grams, okay? So just don't forget that. How much is always grams, not moles. So we're going to put that into a picket fence. So 1.18 moles of O2. Okay, 3 moles of O2 here, 4 moles of iron. So 1 mole of Fe is 55.85 grams of iron. And when all is said and done, this is 87.9 grams of iron. Okay? Last but not least, it's our last problem out of these notes. Okay, let me put this up here so I don't forget. Okay, so how much rush is produced from 12.9 liters of oxygen at STP? Well, this makes our T is 273 K, P is 1.00 ATM, and R is 0.0821. Okay, so N equals, what's my P? 12.9. Oops. 12.9 liters, and at 1.00 ATM, 0.0821, and 273 Kelvin. Okay? When you do this, you get 0.576 moles of O2. So now we get to put that into the picket fence. So it's 0.576 moles of O2, 3 mole of O2, 2 moles of Fe2O3, 159.7 grams of Fe2O3. Oops, sorry about that. I wasn't thinking. Well, we can leave the Fe2O3 down there. Okay, this is a multiplication, not a division. Yeah, and I knew that. I don't know what my brain was thinking. It's late at night. Okay, this is 1 mole. Because your moles got to cancel. And this is 159.7 grams of Fe2O3. When all is said and done on that one, you get 61.3 grams of Fe2O3. And that's pretty much it, and we'll do some of these in class tomorrow. We'll probably do a little bit of a warm-up, but not much of one, because I have to make sure you understand the actual equations. So we'll do that, and then that'll be tomorrow's assignment, and along with, what is it, 964 to 972. And then the following day, we'll do our review sheet, and then we'll get our test the following day. So, on that note, see you later, guys. Bye.